Hi, I'm Anthony Beecham. I've come to talk to you about the metal oxide energy storage process. It takes thermal energy collected from the sun and stores it as a chemical potential energy in a compact, easily contained, inexpensive form. From this stored energy, electricity can be generated to meet demand regardless of the weather conditions or time of day. The whole process operates at a higher thermal efficiency than using the heat source directly, so a greater electrical energy yield is achieved for each unit of collected energy. The MOES process utilises molten salt infrastructure in concentrated solar thermal power stations, CST. These plants use molten salts to collect heat from the sun. The excess is put into storage during the day, and when needed, MOES use the molten salt and its contained heat to drive a chemical reaction to convert metal carbonates and metal hydrates into a metal oxide with chemical potential. Energy is stored as a solid metal oxide. The gas liberated during this stage is also removed and stored. To produce electricity from the stored products on demand, a turbine is driven by superheated steam generated by reacting the metal oxide with the stored gas. The reaction produces a higher temperature than the molten salt from the solar collectors, so the turbine works at a greater efficiency than those operating directly on molten salts. The reaction product returns to begin the cycle again. While molten salt offers a solution for storing energy, there are problems with the current technology. It requires the salts to be stored at a high temperature in insulated containers, which is expensive, bulky and inefficient. There are significant heat losses, and round-the-clock generation is an expensive option. How does MOES improve on this? Greater storage density. MOES can store up to 10 times more energy per tonne than the best practice molten salt storage. The newest and most modern plant, Solar Tray in Spain, claims to be able to produce 1 megawatt hour from each 25 tonnes of molten salt. MOES needs only 3. Cheaper storage infrastructure. Because the metal oxide is storing the energy as chemical potential and it is a solid, it can be stored in something as simple as a grain silo. This is much cheaper than exotically insulated molten salt tanks. Better thermal efficiency. Steam is produced from the turbine at a higher temperature than the collected temperature. In a molten salt plant, the highest steam temperature obtainable in current best practice is around 565 degrees. The metal oxide system can produce superheated steam at over 900 degrees, taking the turbines into their most efficient range of operation. This allows the turbines to produce almost twice as much electricity than can be produced from collected temperatures as low as 450 degrees.
Because MOES has solved the problem of storage in concentrated solar thermal, CST plants, it vastly expands the useful range of these plants. MOES allows CST to be used in tropical equatorial regions and off-grid remote sites like mines. Worldwide, over 100 gigawatts of CST stations are planned to be installed by 2020. CST is already one of the fastest growing sectors in the energy market worldwide. Marketed properly, MOES is likely to be installed in the majority of concentrated solar thermal plants globally as a standard technology. MOES offers greater flexibility and profitability to operators. MOES can be used with almost all new concentrated solar collector types. MOES will save on capital infrastructure costs of the storage silos. MOES can be retrofitted to existing plants, even oil transfer plants. MOES is set to have a major impact on the environment and the way we look at solar power. It makes CST a true baseload provider, which makes uptake of CST even more attractive and viable. In fact, MOES can react to changes in energy market demands better than coal-powered plants. This means a reduction in the use of fossil fuels and their transportation, and obviously a reduction in the total carbon emissions. MOES uses materials that have a very low impact environmentally and are readily available. It offers nothing but a win-win solution for the industry and the environment. The metal oxide energy storage process is set to transform the market with its incredible storage and generation efficiency. It's economic, environmentally friendly, and offers a solution which will be adopted widely by the industry. Baseload renewable power is now possible 24 hours a day, 365 days a year.